The next lesson I like to call 5.4 and a half. Kind of a section to kind of place between 5.4 and 5.5. The text that we use kind of puts a little bit of this information, a little bit of this material into sections 5.2, 5.3, and 5.4. And I like to just kind of hold off on all of it until we get through 5.4, and then we'll just kind of do it all at one time. So that's kind of the reason for this section, and maybe kind of what's in it is you're going to see a little bit of the identities that we've been using in 5.2 and 5.3 and 5.4 as we do this particular section. Now what it's about is solving equations, specifically solving trigonometric equations. You will use a lot of algebra techniques in this, in the way of factoring, as an example. You will also be tied to knowing your unit circle very well for this as well. So if you don't know it very well, then certainly you should have it out in front of you, as that's going to help make sense of the notes, and you won't get behind in the notes as we kind of zip right through it. Now, with all of these problems, you're going to find the directions are going to say solve the equation, or they're going to say solve over the interval 0 to 2 pi. The first few examples that we're going to do together are all going to say over the interval 0 to 2 pi. So we are only interested in solutions as they appear on the circle one time around the circle. That's what the 0 to 2 pi means. So here we have cosine to the third x equals cosine x. The first thing I'm going to do with many of these problems is I'm going to rewrite them equal to 0. So all I've done is taken this cosine x and as a term have subtracted it to the opposite side of the equal sign, so we're looking like this now. Now there are two terms on this side. They each share a common factor of cosine x. If I take a cosine x out, it leaves me with cosine squared x minus 1 equals 0. Now I'm in a factored form. When I solve equations by factoring, we're ready to set the factors equal to 0. So I want to do cosine x equals 0, and I want to do cosine squared x minus 1 equals 0. Well, cosine x equals 0 is the same as x equals cosine inverse of 0. In other words, at which angles x does cosine have a value of 0? Well, cosine is the x coordinate on the unit circle, so that would have values of 0 at pi over 2 and 3 pi over 2. I typically don't write it like this, because then I might tie myself to domain restrictions of inverse cosine, in which case I'd throw out one of these answers. So I'm going to just leave it as this. I usually typically go from here to here. Okay, this equation is the same as cosine squared x equals 1. I'm going to take the square root of both sides, so cosine x equals plus and minus 1. So I want to know at which angles x does cosine equal either positive 1 or negative 1. That happens at 0 and pi. Also happens at 2 pi, but since 2 pi is the exact same spot on the circle as 0, I'm not going to list it twice. So my answers are all of these. Next example has the same directions, solve over the interval 0 to 2 pi. I'm going to begin this one since I see a trig function that's squared. When I see equations with squared things, I think that these are like quadratic equations. When I see quadratic equations, I think solve them by factoring. And when I'm going to solve by factoring, I have to set equal to 0. That's kind of how I'm going to begin this problem. That's my mental thought process. So I'm going to subtract 2 to both sides, giving me secant squared x minus secant x minus 2 equals 0. I'm going to then factor this just like I would if it had said x squared minus x minus 2. Okay? Instead of x times x, we're going to use secant x and secant x. We need two numbers here that multiply to -2, add to -1. So we'll use -2, -1. Solving these factors, I have secant x equals 2 and secant x equals 1. So we have to think, where on the circle does secant equal 2? And if it makes it any easier to think about that, think of instead the reciprocal. Where does cosine equal 1/2? Because that would be the same exact angle values. So cosine equals 1/2, or secant equals 2 at pi over 3 and 5 pi over 3. Now, so same thing over here. Either where does secant equal 1, or where does the reciprocal of secant, cosine, equal the reciprocal of 1, 1. And so cosine equals 1 at 0. Also at 2 pi, but again, we're not going to include 2 pi because it's the same as 0. And that's also why there's a rounded parenthesis here. We don't include 2 pi if it's rounded. Next equation, same directions. We're solving over the interval 0 to 2 pi. It's a quadratic equation. There's actually a couple of different quadratics here, and they're different trig functions too. So to handle a problem like this, it'd be best if we only had one trig function. In other words, I either want all the trig functions in the problem to be secants or all the trig functions in the problem to be tangents. And it doesn't really matter which one you do. But I've got this identity here. Okay, and this identity says that that's a Pythagorean identity. Say I wanted to replace that. I could replace tangent squared x with secant squared x minus 1. That's what I'm going to do from this identity right here. So I would have 2 secant squared x plus, now instead of tangent squared, we're going to use secant squared x minus 1 minus 3 equals 0. Like terms then combine to give me 3 secant squared x minus 4 equals 0. Solving this for secant squared, I'm going to add 4. So 3 secant squared x equals 4. I'll divide by 3. So secant squared x equals 4/3. I'm going to take the square root. So secant x equals plus and minus square root of 4/3. Okay, let's come up here. So we have some more room. Secant x equals plus or minus 2 over square root of 3. Now again, if that's difficult to think through, change this to cosine x equals plus minus, the reciprocal is square root of 3 over 2. That's going to be a little bit easier for us to think about because the points on the circle are built with cosine comma sine, and this is a cosine value, so I want to think of that, I guess. So where is cosine equal to positive or negative square root of 3 over 2? Well, that would be found at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.